Welcome to the Podkey Summary of Refined Accessibility for Custom Controls from WWDC 2026. Today's thread is accessibility, but in a very practical, hands-on way. How custom controls actually become usable with VoiceOver and other assistive tools. The big idea is pretty simple. Once you hear it, if a control has a purpose, a current value, some available actions, and clear feedback, that needs to be exposed just as clearly to non-visual users as it is to sighted users. And once you get into sliders, coffee dispensers, equalizer pads, and gesture-heavy controls, you can really see where good accessibility work stops being a checklist and starts being product design. At the core, every control needs to tell assistive technologies four things: what it is for, what value it currently represents, what the user can do with it, and what happens when they do it. Sighted users often get all of that instantly from the interface itself. A slider track and handle pretty much explain themselves. You see the label, you see where the handle sits, and you can guess how to move it. But if you're using VoiceOver, switch control, or another assistive tool, none of those visual hints arrive automatically unless the developer exposes them on purpose. That's why this matters. When those four pieces are there, the experience becomes discoverable and consistent instead of weirdly mysterious. A standard Swift UI slider is a nice clean example of this done well out of the box. With VoiceOver announces it as brightness 50% adjustable, which is doing a lot of work in just a few words. You get the label, which tells you the purpose. You get the current value, and you get the interaction hint that this thing can be adjusted. Then VoiceOver adds a spoken instruction. Swipe up or down with one finger to adjust the value. As the user changes it, each new value is announced in real time. That's the visual experience translated into spoken cues. The little track and handle that sighted users read at a glance become language a blind or low vision user can actually act on. The custom coffee dispenser is a great example of how a control can look perfectly fine and still be basically unusable through accessibility. At first, it only exposed a generic button label and a static value. So VoiceOver users could land on it, but they weren't really being told what it was, how much coffee was selected, or how to change it. That's one of those quiet accessibility failures that can be easy to miss if you only test with your eyes. The fix was straightforward but meaningful. Give it an accessibility label of coffee dispenser. Provide an accessibility value with the ounce count. Add the adjustable trait, and wire up an accessibility adjustable action so swipe gestures actually change the amount. After that, VoiceOver says, coffee dispenser, 6 ounces, adjustable, and updates the spoken value with each swipe. Now the control doesn't just exist for VoiceOver users, it's operable, understandable, and precise, down to 1 ounce adjustments. Sometimes 1 ounce steps aren't enough, and that's where the pass-through gesture comes in. With the double tap and hold gesture, a VoiceOver user can send raw touch events straight to the control and make finer adjustments, like changing coffee by half-ounce increments. There's a small but important detail here. Setting the accessibility activation point to the current fill level. That means the gesture starts exactly where the visual value already is. So moving in a direction feels intuitive instead of like trying to grab a moving target in the dark, which would be a rough way to ask anyone to pour coffee. There's also the question of feedback. If the app announces every tiny change nonstop, it becomes a wall of speech. So the value announcements are throttled. The app remembers the last spoken value and only announces again if at least 0.3 seconds have passed. That keeps the feedback useful without turning it into audio confetti. Things get more interesting with a two-dimensional control, like an equalizer pad. A regular adjustable trait only really describes one axis well, so it's not enough when the user needs to move both horizontally and vertically. The solution here is custom actions: move up, move down, move left, and move right. Each action shifts one axis by a fixed step and then announces the updated values like frequency 0, amplitude 30. From the user side, This still stays in familiar VoiceOver territory. They swipe up or down to choose an action, then double tap to run it. That preserves discoverability, which is a big deal. The control keeps its multidirectional behavior without becoming a mystery box. Then there are controls that really depend on raw gestures, like tap, pinch, and drag. For those, the Allows Direct Interaction trait can mark an area as direct touch, which tells VoiceOver to stop intercepting those gestures and pass them through to the view underneath. That can be exactly what a gesture-rich control needs, but it has to be handled carefully. Using the Requires Activation option helps prevent accidental activation by making the user double tap before touch events start passing through. And Silent on Touch keeps VoiceOver from talking over the control's own audio cues, which is one of those details that sounds small until you imagine trying to listen to two interfaces at once. There's an important accessibility reminder attached to all of this, though. Direct touch can't be the only path. Not every user can perform those gestures, so there still needs to be an alternative, like custom actions, if you want the control to be broadly accessible and not just technically impressive. That's the through line in all of these examples. Accessibility isn't about sprinkling labels on top at the end. It's about making the control's meaning and behavior fully available in whatever mode the user is actually using. And when that's done well, the experience feels surprisingly natural, which is kind of the goal. Nobody should need a secret handshake just to adjust brightness or pour coffee. This episode was generated by Podkey. Create your own at podkey.fm.